So guys, here the confidence intervals that we are going to discuss for the large samples today. Okay. See, let us take a look. Let us take a look at this part. The point estimate for the population. Okay. A point estimate. We have to understand two things: point estimate and interval estimate. What is the difference between this point estimate and the interval estimate? If you take a look at this point estimate for the population, it is none other than a single value estimate for a population parameter. The most unbiased point estimate of the population mean is the sample mean. Understand? What I just wanted to highlight this here, the mean point of the mean. Can you all tell me like one thing? I have a population data. Okay. When we have the population data, we can calculate the population mean. Right or wrong? When we have the population data, we can calculate the population mean. I have taken a sample of size something, some x, and I have calculated the mean of that sample. Will the mean of the sample is equal to mean of the population? Huh? What is it? Mean of the sample is equal to mean of the population. How come? How come, boss? This is what we have discussed in the sampling distributions, right? See, when we have the full length population data, out of the population data, when you are picking only one particular sample size, how can you get the same mean value of what the population mean is? Look, I have already told you yesterday. See, I have the population data something like this. Okay, this is my population data. I have taken the sample size of 3. Okay, what is the mean of population here? Tell me guys. 8, 18, 20, 30. 30 divided by 5. 5, 6, 30. 6 is the mean. Right or wrong? 2, 4, 6. 6, 6, 12. 12 divided by 3. This is mean, sample mean. Right? So, the mean of the sample will never be equal to the population mean. But we will try to estimate the population mean when we don't have the population data, when we are collecting only the sample data, we will try to estimate by clubbing all together of different samples. Understand? This is what we are done, right, with the sampling distributions and all. Yeah, even mean of samples mean also will not be equal to the population mean, but you can say that it is close to or approximately may be equal to population mean, but you will not get 100% sure that both are equal. This is what I'm asking. That is what I'm asking. Okay, so that point estimate, that is what the estimate, that is what I call it as estimate. A point estimate is a single value estimate for a population parameter. The most unbiased population estimate of the population mean mu is the same if the sample mean x bar. Okay, the most unbiased means, what do you mean by unbiased? The most unbiased means maybe you might be having 1000 in your in the current 2, 4, 6, 10. I have given you the values, population data values. Let me say 1000. Okay, if I'm going to take 1000, the mean of value will be definitely going to be a biased value towards that value. Okay, so that's why it is mentioned it here as the most unbiased point estimate of the population mean. Okay, mu is the sample mean x bar. We are approximating it. So a random sample of 32 textbook prices is taken from a local college bookstore. Find a point estimate for the population mean. Okay, if you can take a average of all these things, you will get nearly 74.22. Interval estimate. What do you mean by interval estimate? An interval estimate is an interval or the range of values used to estimate a population parameter. Okay, interval means, see, the same kind of samples you will take some 100 for 100 samples, we may get 100 different means, right or wrong? One mean value may be 2.1, another one is 2.2, or another one is 1.9, something like this. Okay, so different, the range of values can be considered as an interval. Okay, the estimating that interval is nothing but an interval estimate. Okay, how confident do we want to be that interval estimate contains the population? This is what the main important point, right or wrong? Okay, so point estimate and the interval estimate, the level of confidence. See here, the level of confidence is the probability that the interval estimate contains the population parameter. We are trying to identify the probability. Why? Because we have got the interval estimate, we have the population data. Okay, we don't know the population mean, we don't have the population data, but we know the population mean or approximated population mean, or we might be understanding to we should know that when we don't have the population mean, when we have only the samples, we should do the point estimate and the interval estimate. Okay, and we need to understand whether we have how much probability it is, how much level of confidence is the probability. Okay, so how much probability that we have the population mean will be within that interval estimate. All of you with me? Okay, so here if I'm going to say this confidence interval is represented with the C represents the critical value actually. Okay, or the area. Okay, otherwise you can make it as alpha, whatever it is. C represents the area under the normal curve between the critical values, whatever those critical values may be. Those critical values may be -1 and 1, or -2 and 2, something like this. So at that point of time, the remaining area of this particular curve will become 1 minus C. Okay, when you wanted to have that particular two side, left side and right side graphs, that 1 minus C should become halved. So half 1 minus C and half 1 minus C on the both left and right hand side, these are called the critical values. Okay, whereas minus ZC and plus ZC can be considered as critical values in the level of confidence. Okay, let us see. If the level of confidence is 90%, this means 0.90 is the area, and that we are 90% confidence that the interval contains the population mean. This interval definitely contains the population. This means the population mean will be definitely lying under this particular interval. Okay, so the rest of the 0.05 should be distributed on the both of the either of these sides. So the corresponding Z scores are plus or minus 1.645. Okay, when I'm going to take a 95% confidence interval, plus or minus 1.96. When we have the 99% confidence interval, plus or minus 2.575. Okay, so something like this, we are having different levels of confidence, which are common levels. Okay, which is 90 and 95 and 99. Okay, but based upon the researchers, they used to suggest or advise to go ahead with the 95% confidence intervals rather than going for 90%, which is little bit lesser, or 99% which you are expecting something closer. Okay, so instead of going which are almost different, so it is advisable to go ahead with the 95%. All of you are with me? All of you understood this concept till now so far? Why? Because tomorrow we are going to expand and we are going to finish this confidence intervals where I will discuss about the margin of error in the tomorrow session. Okay. Then we will go ahead with the intervals for mu and finding confidence intervals and all. Okay. I will take some different examples tomorrow. All these examples, sample size, t distribution. Tomorrow we are going to discuss about this t distribution. Okay. And chi-square distribution also. We are going to look after the chi-square distribution and t distribution. Okay. So, okay, guys. Tomorrow we will meet again. We will discuss about this confidence intervals and we will close the t distribution and the chi-square distribution in the tomorrow session. Okay, all of you. Hmm?